carbon, hydrogen, and oxygen. In this lab, we are going to run an electric current through acetic acid and break it down into its components. The carbon and hydrogen and oxygen will be broken down into carbon dioxide and hydrogen gas. This is the piece of equipment we're going to use to separate carbon dioxide and hydrogen from acetic acid. The acetic acid will be poured into this tube here, which connects to this H-like tube. The acetic acid will cover these two electrodes. Electric current will be supplied by the power supply, which is connected to each of these two electrodes. And electricity will run through the acetic acid. The electricity is the power needed to separate carbon dioxide and the hydrogen from acetic acid. So the bonds will be broken by this electric current. One of the gases will be collected through this tube here in a test tube. The other gas will be generated in this column and will be collected over here. First, we must weigh a clean, dry test tube. We're going to use an analytical balance to do that, to make sure that we get as much precision as we can. Here's a mass of the test tube. If you can't read it, it reads 29.5528 grams. 29.5528. Next, we got to weigh out the amount of acetic acid that we're going to start with. After zeroing the beaker, the mass of the acetic acid, if you can't read it, is 149.1969 grams. 149.1969. The test tubes are filled with water so that when gas is created, it will be displaced by the gas, and we can have an indication of when this test tube is filled with the gas that we're concerned with. The acetic acid goes in the top tube. Turn on the power. And you can see the gases that are being generated. The gas we're concerned with is on the right-hand electrode, carbon dioxide. And here's our collection tube. Now we're going to let this run for a while until the collection tube is completely full of the carbon dioxide gas. The hydrogen gas will not fill the tube. And so we're going to stop when we have a full tube of carbon dioxide. When the collection tube is full of carbon dioxide gas, we'll kill the current measure how much carbon dioxide gas was collected and how much acetic acid was actually broken down. We measure the weight of the test tube and the gas collected along with the stopper. Subtract the weight of the test tube and the stopper, and we can get the weight of the carbon dioxide gas that was collected. And here's the weight of the carbon dioxide collection tube. 29.5572 grams. 29.5572. Now we get the weight of the acetic acid that was unreacted. And that weight is, after zeroing the beaker, 149.1923 grams. 149.1923. Now, with this information, you should be able to tell me the carbon, hydrogen, and oxygen mole ratio and come up with an empirical formula for acetic acid in terms of carbon, hydrogen, and oxygen.